Assalamualaikum dear viewers, Shoaib and Dayo here again with a new experiment of the electrical machines lab. Today we are doing the experiment of the alternator again, but here we are doing the experiment related to the alternator is the open circuit test of the alternator. In the open circuit test of the alternator, we have to find out the no load voltage E0 from the stator side of the alternator by increasing the field excitation. Obviously already you know that the terminal voltage of the alternator E0 is totally depend upon the field excitation which is to be given to that field winding of the alternator. If the field excitation of the DC field excitation of the alternator is increased, then our output voltage E0 will be increased. So for this purpose, today we have to conduct the open circuit test of the alternator to vary the amount of the DC field excitation to the field winding of the alternator. We have to analyze that what will be the effect on the stator voltage by changing the field excitation. So what kind of the modules in this experiment that we are using? We need the primer to rotate the shaft of the synchronous generator. Already it is also alternator can be called as a three-phase synchronous generator. This is a three-phase synchronous generator. We need DC power supply to excite the field winding of the generator, and for measuring the no load voltage, we need to measure the our stator voltage from this voltmeter. So before this, we have to analyze our operation. That what is the operation of the alternator? The alternator, according to the construction point of view, alternator has the two windings. Number one is the stator and the second one is the rotor. The stator part of the alternator is the armature winding, and from which we are taking the output voltage, stator voltage, and state in which the three-phase currents are being induced. And their second winding is the field winding. The field winding in the alternator is the rotating winding. And the purpose of the field winding is to produce the magnetism in the field winding of the alternator, and that magnetism can be produced by applying the DC voltage to that field winding. So already the shaft of the alternator is rotated with the help of the primer, and when the field winding of the alternator is excited by the DC source, the lines of the cuts of the flux are maximum, and then what happens? Induced EMF and induced voltage is produced in the stator current. So what we will do in the experiment, we have to connect the voltmeter in this, and we need to increase the excitation and observe the output voltage of the alternator. So before this, it was the demonstration of this experiment. Now we are going to conduct this experiment, assemble all these wires with the modules to analyze our results. Here we have to first of all analyze our experimental diagram that we have to implement on this strainer. So see what this diagram represents here. So this is the our field rotor side. Okay, we need this field excitation source. Positive and negative, they will be connected to this field windings of the DC generator of our alternator. And these are the stator, and from which we can take the two wires to connect a voltmeter in parallel across this to measure the no load voltage. And also this is the primer portion. We have to give the positive and negative supply to rotate this permanent magnet DC motor. Obviously it will act like a primer to provide the mechanical energy, and when this shaft is rotated, then what happened, our mechanical energy will be converted into the electrical energy with the help of this stator, and we will observe the voltage. We can increase or decrease the excitation voltage from this, and we will observe the output voltage here, that what will be the result. Already I have taken some readings too. For example, if we have take the reading of the 6 volt DC we are applying to this, then we have obtained the 200 volt E naught in this experiment. And if we have the 11 volt field excitation we have applied, we have got the 400 volt AC. So we have to make the connections on this trainer and analyze the results. Okay, first of all, connect the prime mover portion. So this is the positive. I am going to connect the prime mover portion here, positive with the positive, and simple negative with the negative. So prime mover is already connected. Now we have to connect our alternator portion. Now alternator is connected in star. So the last 3 points should be shorted now. And what we have to do from here, we have to connect any two phases with the voltmeter to analyze the E naught, which is the no load output voltage of the alternator. Now one thing we should connect now here, this is the separately DC power supply. So positive of this is connected with the positive of the alternator field winding, and negative of supply is connected with the negative of the alternator field winding. Now start the prime mover up to the 3000 rpm, and now we have to increase the field excitation voltage 6 volt and the 11 volt to obtain the our field excitation, to obtain our stator voltage, which is called the E naught voltage. So we have to rotate our prime mover up to the 3000 rpm. Now we have concluded from this open circuit test of the alternator is that if we are increasing the excitation, the lines of the cuts of magnetic field will be maximum when in the rotor winding. What happens? The stator voltage is increased, because already you know that the stator voltage of the alternator should be maintained, or terminal voltage of the alternator should be can be easily maintained by the field excitation, which is to be given to the DC field winding of the alternator. So increase the excitation, increase in the stator terminal voltage. Decrease the excitation, decrease will be the stator terminal voltage, by which we can easily maintain our terminal voltage for the parallel operation of alternator in our power plants. So this was the experiment, that was the open circuit test of the alternator. I hope you have understood the experiment, even though the circuit diagram and the readings. So at the last, again, please don't forget to subscribe my YouTube channel Shoaib Dayo, and that your subscription motivates me to make the more contents and videos related to this electrical machines and electrical engineering things. Thank you very much.